Good evening, everyone. Hi, hi. Hopefully... Oh, you can kind of see me. I need to adjust a couple of things. There we go. Cool. Took a little bit longer to get everything ready than I thought it would, but I guess that's given us time to have people join. 3 people so far. My bitrate is low. Why is my bitrate low? Indeed. So, today's stream, as you can see from my plan here, I actually have got my scope ready to go. Well, I haven't got it on my desk right now just because space is a thing. But the idea with today's stream, we've got the replacement resistors. In fact, this is probably not entirely in focus. There we go. And I've got some more LEDs. So between those two, we can fix last stream's mistakes and put the right resistors on and see if it does fix the brightness issues. I have some spare oscillators in case the one that's on here is just dead for whatever reason. And I want to try and get to having more of the keys on, but more importantly, getting to test the drivers, the row decode, or the column decode, sorry, get the right half of it, so that we can start to write the firmware for that part of things. So, I need to quickly grab some solder, get the iron heating up, and without any further ado, we will get going with this. How is everyone, by the way? Fair enough. Oh, talking of things that need to do. Disable notifications, there we go. No more bing bing. Oh. Oh no. My wife's got hiccups. Power PC is good though. I love it when I get desiccant packs like that. So easy to deal with. There they are. So much desiccant for so little LEDs. Yeah, absolutely massive desiccant pack in there. Like, that's the bulk of the weight. Jeez. I think it might be, yeah. I actually need Eagle Up, and I don't have Eagle Up yet. go. Wait, I actually need to tell OBS to not use my panel as the schematic. Yeah, thank you. And use the board as the board. Oh, that was the keycad one. Bollocks. God, this is fiddly. There we go. So, I'm going to start with the hash tilde key here. Aww. That's a shame. Need the data sheet for the LEDs up so I can remember what the lead frame orientation is. Okay. I'll fix the camera in a moment so that you can see exactly what I'm doing. That goes that way around. I mean, to be fair with regards to this 1K Challenge 2020 thing, just get a Blackmagic probe. Sorted. Where's the endermise holder gone? Oh, there it is. Yeah, I mean, you could get a Blackmagic probe and a Glasgow as well, and that would be almost every need met. Yes, you do. That would be a nice stream for you to do. Well, yeah, I mean, I get it. Assembly is a long, arduous process that you aren't really much enjoying the prospect of because, you know, it's hard. And you need spoons for it. Yeah, don't try and power up the expensive keyboard with the tweezers still on it, shorting things out. That would be bad. I've just soldered that one LED on. I'm going to just see if that works. No. It does not. Huh. Brand new LED. I know that that LED should be good, and it's not working. We can test that. I apologize for the slightly burpiness. I'm actually going to skip this song because this actually has got lyrics later on, and it's kind of hard to talk over. Let's see. Should be this pin over here, which should be pin 2, is power. Curious. Well, I'm getting power switching going through the LED. As far as I can tell, at least. I actually can't tell what's going on with that one. But I need to clean the flux off to really be able to see what I'm doing, I think. So I'll go and grab my bottle of isopropanol and a kitchen towel. I will be right back. And back. I completely forgot to ping streaming. Oh, and I've just noticed I got my stream title completely wrong. Go me! That tells you how together I am today. Educational engineering. Design. That'll do. Oh, I probably also want to add programming and software dev in there. Welcome back. Hopefully the title of the stream should now be correct. Does help, right? So it is orientated and set exactly the same way as this LED here, and yet it still doesn't want to work. This is puzzling, but also potentially means we've damaged the driver. Or there's a pin on every single one of those 3 drivers that is not connected right. I'm quickly going to look in the schematic though. Let's see, this is the key we're having problems with. And this puts it as being the second pin in, pin 23. Which visually looks fine. And that should be 5 volts. Let us check. I'm also going to check that the 5 volt connection is happy. Let's put that here. Does that work for you? Not really. There we go. This was pin 3. Yeah. Yeah, that definitely has power where we want it going. Actually, before I put it on that mode, let us quickly go back to there. That's 5 volt in. The easiest place to test it's probably here. Hello. Why am I not getting a connection between these two? What the? Well, it shouldn't be though, that's the really weird thing. Oh, it is! Well done, Lethal Bit, thank you. Okay. Pin... oh, LED... maybe. We'll go and have a look at it in just a second. We'll fix this one first. Pin... oh, LED, sorry, 73. 71, there it is. Ah, oh, that's, I don't have an X-Acto knife. This is gonna suck. I don't have a bad pair of tweezers, but I do have nail clippers, which have got a really sharp tip to them. I just want to see this repaired first before I do damage to the board. Hey, there we go. That should now work. In theory. Let us do surgery. Yeah, okay. Sure. There we go, I can see some copper. I think that may have already done the job. Welcome, Jiggly Girls. Nice to see you here. Let's see if that bodge works. No, not yet. What I'm probably going to have to do then is clip a tiny piece of wire and stuff it in the joint. Or make a solder blob and a half. This is not going to be pretty, but that's okay. As long as it works. No, I don't. But I do have yellow wire, and I can cut a tiny piece off and stuff it in there. Yeah, I don't do surface. Sorry, I don't do through hole, so I have no bits to save. Step 1, have bits to save. Step 2, save them. I kind of skipped on step 1. What was it I was going to quickly grab? Oh yeah, wire. Oh, I know what I was going to initiate. I need to grab some extra music down for the stream. Just quickly get that running while I'm soldering. Oh, curious. Error 431 from SoundCloud. Could somebody else check if SoundCloud is up or down? Because it appears to be not up. Ah, interesting. It was an error 431. Really? I've never had that happen before. Okay. Cookies. See cookies and site data, SoundCloud. So, bad design, is what you're saying. Yeah, I can't even get a log out page though. So, Lethal Bit is right, I'm gonna have to do the whole kill my session. Yeah, this is a white page. Well, I'll show you. This is what I'm getting. Well, I'm in the in the cookie settings because I might as well blow away things like the API cookies as well. Yeah, that won't work, Obliterous. This is a web server level fuck up. It's great. Ah. Well, I'm in the SoundCloud. Sorry, in the F12 settings. Where the hell do I poke? Because something is balked. Application, okay. Okay. Hey! Sign in. Oh, that's the wrong sign in. There. Oh, and they're just dealing with it in a really dumb way. Got it. Wonderful. I mean, either which way, Obliterous, the effect is exactly the same. We'll get back to the content in a second. Cool. That is now doing its thing. Let us see what I can do with some wire. Yeah, that's what I read out as well, so that matches nicely. Wonderful. Gotta love these tech sites and their infallible technology, didn't you know? Let's not put that on the keyboard while I'm doing this, I guess. That makes it both a hell of a racket and really isn't good for it. Yep. What it means is that they've not handled something on their side correctly and they've got a really badly written piece of web app. Because it's a really hard error to get into in the first place, and it is entirely on them. Ah. No, really, I want you to go exactly where I'm putting you. There we go. Yeah. Welcome, Amy. tweezers over there. Good. Go me. Oh. Welcome. Goshi Kudesukita? I think that's right. It's a long name, so I apologize if I've got any syllables wrong. Doesn't help it is in dark green for me. Ah! Oh yeah, okay, I read it now. Which, because Japanese, ends up being pronounced more like Goshika Desuta. Which, yeah, I can see it. Alright, let us see if that now has a proper connection. Meow. Yes, indeed. This is my own 6-layer board design. Ha! I think we've got a connection. That's good. Let's see if that one now works. Hey, what do you know? Yeah, really. You're telling me. It's missing its green. By comparison to just not working, it missing its green is easy. I'm currently gonna poke a bit with the board. So it's this green signal here that's not working. What it probably is I've gone and accidentally shorted 5 volts and green together. But we can fix that. See if that fixed that. No, it's still missing its green channel. I'm not sure why. But we can come back and fix that later. I'm happy that it works in some capacity at least. Let us do left alt then. Which is this key right here. I can actually see it's not. I don't know if you can catch this on camera, but in here you can just see the pad extending off into under the mask. And a visual inspection in Eagle says, yeah, it's connected. It was just a dead LED at the time. I think actually this one was one where we had one of the channels was out. Yeah, we can do a test all the same. This is the whole thing. Yeah, that's got a good connection to 5 volts. Let's see if I can test, for example, green here. Where does the green go? It goes to the second pin up on the middle driver on the side. Yeah, so green goes where we want it to go. I'm gonna say the others are probably fine, given the power connection's fine. So this one's probably not a dud. When I see wires on all of the other 3 pins, so... Come on. I need to clean my tweezers a little bit. Nice and fluxy. Ah. Ah. Please, would you stop turning around on me on my finger? Thank you. Should be that way around. Let's not fry an LED, that would be nice. Oh, I'm soldering completely the wrong LED. whoopsie. Why is it looking so good already? Oh. Don't mind me. Right, let's clean that. So Emily does things. The answer to that one is actually quite interesting. Flux burns off even on the tip of your iron, and I actually really badly need fresh flux every joint on this board because the things are just so tiny. The amounts of solder in question are just so tiny. So what I'm doing that for is because while I have a nice big blob on my tip, it won't flow nicely and create a good quality joint unless I add extra flux in some way. Can I copy link location? Thank you. Tubes, huh? Oh yeah. Big tubes. I mean, we are talking about Obliterus here, Lethal Bit. He is kind of an RF king. Just gonna zoom that out a bit so you can see while I have to move the board around a bit. Welcome, Grad131. Hey, there's that LED working too. I can't tell if all the channels are lit. I think they are. So, yay, that's two fixed. Yeah, I'm a little under-equipped because, well, I'm working on a very tight budget, so I've only got a flux pen like this, and this stuff is far too liquid and burns off far too easily to do that. So I'm currently using the flux that's in my solder for that kind of thing. I plan to do some upgrades soon, but you know, that requires a month or so to tick by for enough money to build up in an account to be able to do that. It's one of the things I bought very recently for this project. Unfortunately, they haven't yet got here, but they have shipped. Is a set of keycaps for this. So. Right. We now have one more LED left to fix, and then I can do the resistors. Oh. Just trying to push everything up my desk while the isopropanol has its top off. Go me. We're going for the one down in here, which, there we go. Also, I've got so much solder here, and it's so old now, like I've had it for half a decade, that I really don't care if I burn through a whole pile of solder. Solder is cheap enough that it's not a big deal. So I've got pin 1's down here, so I've got to make sure I orientate the LED differently to the other two. Now, as I recall, this one had a broken red channel before. Cool. Actually, I won't leave my tweezers there because I'll probably forget that there. You're very welcome. I'm glad that we found that, because I know you were getting deeply frustrated before. That just went all kinds of messy. Right, let's see if that one works once we've cleaned it. We know with that one we're only looking for the red channel to come back, so... Looks pretty good. So it's this one right here, we're looking for it to come good. Yeah, it hasn't. Interesting. Where is the red channel in that one? So this is this one. It's green, blue. Ah, there's the red channel. Pin 1 of... this is pin 1 of the cursed one. This is entirely possible that with this one the driver's just dead in that channel. Because this is the one that I had to do some very heavy rework on. So we are looking at this driver here. And we're going to do a continuity test first. So it's the end pin here. See if I can get more of this in view for you. There you go. Oh, that's a hell of a reflection. Okay. gets tangled, it's always fun. So, it's this end pin, and there is a connection, but it's a little bit flaky. So I'm inclined to retouch that driver with a little bit of solder. See if we can get a better joint there. See if I can make this so you can see what I do. I've made my life really complicated by the fact I have got a key in the way. Oh, the driver could, yes, but as other people who've been watching the other parts of these streams can tell you, replacing one of those driver chips is a royal pain in the ass, so I'd really rather not have to do so. For context, there are 3 inner layers connecting the ground plane of this chip. This is a 6-layer board. But this is also my prototype design, so if we've got a problem, then I'm not too choked up about it because we can fix it in the schematic, so we can, in the respin, that I will eventually get to do, and that version should then be fine and work fine. Before I put power on it, actually, let's quickly clean that. This is a non-conductive flux, but it's still just good practice to clean it anyway. Okay, yeah, that joint now looks a lot nicer than it did. Yes! Yes, it is. That's actually a very good description of it. So I'm avoiding doing that if I can do it, if I can avoid doing it again, because that was not a fun stream. The cycle time was around about half an hour with my big tip. Ow, I just burned myself. Go me. Try to pull this tip out. This bastard of a tip. Yeah, I will do that lethal bit. Thank you for that offer. Sorry, I'm just having a moment where I've gone and managed to burn myself on my soldering iron, which, even though it's now off, and has been for a little while, still stays pretty damn hot for a while. I am quickly going to grab some aloe vera. Lucky I have a plant. Oh, that's better. Straight up just a piece of aloe vera. It's not just an LED keyboard. The key matrix itself also has some fairly special stuff going on, and it's also to do with the firmware. We're writing firmware for this from scratch, so it's going to be interesting. So let's see what happens with this guy. Yeah, that LED is just not happy. Well, that driver is just not happy. So yeah, that's probably going to be something that fixes itself with the respin. I'm fine with that. That's a really nasty burn I've given myself. Oh well. At least it's just the top layer of skin. I can just feel it, that's all. So, with all this in mind, please turn on properly, thank you. Let us replace some resistors, because they're all currently wrong. They need to be, we think, 15k ohm. Now, the resistors, for those who haven't seen my previous streams, these drivers of resistors here are 25 kilo ohm, which puts around about 2 milliamps of current through the LEDs, which testing has shown is a little bit too dim. The rest of these drivers, going that way, are all running on 9.8 kilo ohm, 9.8 kilo ohm, wow, words are hard, resistors, which puts about 5 milliamps of current through the LEDs, and is a little too bright. Like, bright. So, hopefully these resistors should be around about the middle ground, because it's a logarithmic curve and fun. So we calculated it's probably around about 15 kilo ohm to put, I think it was 4 milliamps of current or 3.5 milliamps of current through the LEDs. And that should be around about right. So let's find out. Right, there's 3. And I'm going to pull off the 3 resistors here next. So let's get... So, this guy here, here, and here. Yeah, should just about be visible. I know I'm not choked about doing that. I just used the iron at a very oblique angle to the board to flood both joints with solder, pull the resistor off and then just sponge it off because, well, they're cheap enough, I don't really care in this case, because they're like 10p for 15. This is going to be the fun part. Also, welcome back, Obliterate. Cool. That's 2. Well, that went ping. Yeah, changing the current limits. Having had a resistor go ping. Well, I guess I'm getting another one out. How many did I actually end up buying? I think it's 20. So we've got a couple of pings we can tolerate. Where's the count gone? I don't see a count. Oh, there it is, 20. Yeah, I've got 20, so we only need 15. Well, let's not have 5 of them go ping on my floor. That would be nice. That is not on straight, but it doesn't have to be in this particular instance, so that's okay. Now I'll just quickly freshen the solder on the joints and make sure there's enough. Yeah. Yeah, the next ones I'm going to change to the ones right on the end here. The really annoying ones, we'll do those next. So it's this one, and this one right here. Just, yeah, so pleasant. Well, if you've got a suggestion that is on, say, Farnell, do please throw it in chat. You're welcome to do that. I need to get some extra tweezers anyway, because I shouldn't really be doing chip rework with these. They're for passive parts, really. So, you can see the profile's really good for passives, but the profile's not so good for, like, chips. I just managed to shake those all over the board. It's frustrating when I do that. And it's not a coffee shake, before anyone says that. I actually have a not a genetic. Well, it might be genetic. It is in the family. My entire family on my mum's side has a shake. So, go me. Pretty good. Good. That's more or less on that. Let's quickly refresh the solder. There we go. Oh, sorry, you cannot see what I just did there. There we go. I'll take your word for that one. So it's this one here, there, and all the way down here. I had to get a little bit creative with where I put these, although why did I put that one down there? Okay, that one needs revising, but we'll do that once we convert the schematic to KiCad, which I actually do plan to do later in this stream, because it would be nice to actually have an open source schematic, because this is an open source keyboard. An open hardware for that matter, I should say. Right. No, that's still upside down. My tweezers are still really super fluxy, this is not so great. So how's everyone doing? What's up? How's it going? While I work on these. Hey, nice. I'm glad to hear that. Ah! Well, welcome to the family, Emily. It's a good time over in this camp. You don't have to deal with updates quite so horribly, for example. What was your degree in, by the way? What did you read? Lack of spoons is a mood. This is going swimmingly. Wow. Let's just quickly remove the streaks of metal from the board. That's always good. I'm thinking about the fact you have to reboot on basically all updates with Windows, whereas with Linux, you don't. It's only the kernel. Ah, fair enough. I'm a software engineer by degree-wise, although I did embedded systems as my primary focus, but I do electronics in my free time. Yeah, you can indeed K-patch a kernel. So you don't even necessarily have to reboot to upgrade kernels with Linux. Which, if you're like me and you have a lot of consoles open to a lot of different things and a lot of state, matters a lot. Or if you're also, you know, dealing with a really big machine that can't go down. I sysadmin for money, so, and I sysadmin supercomputers, so that kind of matters to me. Oh yeah, that's better. So, half of these are now running at the lower current, or the new lower current, so this is all the lower current side of things, which if I turn the overhead lighting off, there we go. So that gives you an idea for like how well the keys are illuminated and all of that fun. While these over here are still at 5 milliamps. And actually, you can kind of just about see the difference around here. It's just a little less glaringly bright, whereas this side is oof. So this is definitely the right move. We've, I think, got around about the right current going through these now. So I'll do the last two lots of drivers, the last 6 resistors. Oh yeah, that would be great, wouldn't it? I actually don't know their rationale for why they don't do that. I would be fascinated to know though. I mean, even that makes a huge difference when your system takes Yeah, exactly. You can suspend a system to disk. So, yeah. They could do it. Warm rebooting's good though when your system takes, you know, a good half an hour to boot in the first place. And a reboot that's warm would be all of 5 minutes. I don't think the BSS section moving would matter, because if you're not saving kernel state when you do a suspend for kexec, then you're booting a fresh new kernel over the top of the old one, having de-knitted the hardware as far as you can without actually issuing a reboot. Oh, I'm not surprised, Obliterus. I'm really not surprised. That half-hour figure is the actual number for one of our pieces of gear at work. Big memory machine. People talk about, oh, I've got 64 gigs of memory and it's huge. That's tiny. That's really tiny. This machine has 1 terabyte of memory. Yeah, but this is a singular node. Well, it orchestrates as a singular node that has that capacity of memory. The node physically takes an entire rack, but that's a slightly different problem. Yeah, all presented as one singular machine. Well, in our case, it's more NUMA. It's got a really big NUMA backplane on it. Dear. That was terrible. I hate it. No. Just no. Okay? Okay, fine, it was a little bit funny. Just now I have that song stuck in my head, and it's not great to have that stuck in my head. It is an awfully catchy song, yes. Stress on awful. Okay, no, actually, to be fair with it, it is actually a pretty good song, but it is ridiculously catchy. I don't want to tango with that one. That one tangos with Twitch rules to do with lyrics and also with YouTube later. I want to be able to stream next week as well, you know. Nice. So in other words, you now know every video that can rickroll you. Have you published the data somewhere? Alright, one more set to go. Ah, it's these ones right here. Mmm. Yeah, well. Right. Alright, we've got 4 left of that lot. That's nice. I will now go and grab the bag for the LEDs so I can put them away. They've been resting on top of the static dissipative, because this is not static shielding, this is static dissipative. Something to know. I feel like I have to explain it to far too many people. People still don't realize or know, for whatever reason, that this kind of bag, this is static shielding. This can take a hit and conduct around the parts that are sensitive, but it can't dissipate the charge. So the top surface can become charged, but it won't conduct into the parts. This stuff, this pink, indicates that this is static dissipative. That is, it can dissipate any voltages that arise on its surface and any current flow, but it cannot shield what's inside. It's only when you combine these two that you actually have full static protection for ESD. Fun thing to know. Also, yes, welcome back. Yes, that's exactly how those two work. Well, actually, it's also that the static charge can generate on the outside of a silver bag. The reason it is silver in color is because you are looking through a very fine layer of metal. The bag is physically metallized. Whereas the pink bag is made of a material that is mildly conductive, i.e. it's like a pretty crap 1 mega ohm resistor. Nice. Interesting. As for pink bag being a semiconductor, I did not know that. I know that the bag is a kind of nitrile rubber, or it's rubber-like at least, but I did not know that it was a semiconductor. Today I learned. And the same rules, by the way, apply to the boxes and bubble wrap, etc. that you can get in pink and metallized. Anything that is that metallized color is shielding, strictly, and anything that is pink in electronics, that is a bag of some kind or packaging, is dissipative only. Right, we now have all of those replaced. Let's just check that it still works, of course. So hopefully this side still lights up. That's what we're looking for. Yeah, that's pretty good. That's the new, better brightness for the board. That's not bad. Let's actually quickly dig a keycap or two off of my other keyboard, my main keyboard, and check to see what it looks like on here. So let's go for H. G. F. And let's do this bottom row here as well. Nope. Go on. There we go. Yeah, that's pretty good. There is a little bit of light coming through for me, but I actually need to revise the board in one very interesting way. The LEDs are actually on the bottom side of the key, and they should be on the top side. So the keys are all backwards on this particular iteration of the keyboard, which is why we don't get very much light firing up through these keycaps, but it's enough I can see that it will work when the LEDs are in the right spot. I can actually simulate that. If I put the cap on backwards, and you can now see there's quite a bit more light coming through that H. There you go. Which is at 50% brightness, which is what it's currently at. That's a reasonable amount of illumination. So I'm happy with that. Well, yeah. Have you any idea how expensive it is to get custom-made keys? Keycaps, rather. It's kind of obscene. I've been struggling with trying to get the right caps for this board. I'll skip this song. Right, having done that, I'm gonna go grab the bag of keys, having cleaned the board once again, because we now have flux residues right where we don't want them before we put keys on the top. And we're gonna start soldering some keys on. Woot! Oh, lots of metal splatter around that one. Better. Three more to go. Yay. I love that this solder mask cleans up this easily. It's a really nice solder mask. JLC really did a good job with this board. For those wondering where I got this board manufactured, and how much it cost, I got this made by JLC PCB. Yes, that Chinese website. And it cost all of £250 for 5 6-layer boards. By comparison to the next best offer for 3 that I could find, €1,000 for 3 from a slightly closer to home manufacturer. Turns out trying to get boards this big and this many layers is just really quite hard. They don't do them particularly. Who knew? I'm gonna quickly go put the paper towel in the bin because you. I also need to grab the bag of keys. That will help. Right. I'm just gonna grab a handful and let's start putting them in. I'm gonna have to unbend pins anyway, so... Oh, this is gonna be entertainment. Now, the question I've got in my head is, where do I start? And I think I'm gonna start down here with the escape key. Which, This is the problem we've had with all of these keys because of the way that that Mouser shipped them to me. Some of the pins end up a little bit bent, and it's not great. Ah, go in the hole. There we go. This is almost certainly not in the right spot now. But we'll solder one leg on, like that. Yeah, the problem I've got with that is I then have to flip the board back over anyway every time because I have to check the alignment, and as you can see with this one, or I hope you can see with this one, that ain't on straight. So I've now got to straighten it. Which is decidedly easier without other keys around it. Need a wave soldering machine. Yeah. That'd be lovely. That's not straight still. That's better. Oh, that reminds me, this one here ain't flat on the board. I can't heat both ends with the iron like that. That's this one here I'm doing, and let us change the tip. Because I kinda need to. That should about work. Trying to make this so you can kind of see what I'm doing. And I'm pressing on the key on the other side. Hey, it's flat on the board, who knew? The one next door to it as well needs doing that. So we'll do just the same here. No, it didn't do it. Need to heat for a longer time. Hey, there we go. I'll clean up the joints in a second. Oh, that last one actually is a little skew-whiff. better. There's one more that's like that. There we go. Oh, that's even worse now. Sorry, you can't currently see what I'm doing because this just sucks to do. It's better. Still a little off. Hey, that's better. There we go. Okay. Oh, I accidentally gouged some of the rubber surface of this. Don't worry, it's literally a decade old, so it owes me nothing. It is starting to fall apart. If you're wondering what I'm doing here, by the way, I'm just setting the tip at the right angle, having changed it back over. Which is a very personal preference thing. It's quite fun. So for all of the ones I've just done where I've ended up having to reflow across keys, I'm going to go in there again with some fresh solder, because I'm not happy that those joints won't be a little bit crusty now. And we'll just quickly add a little touch of extra fresh solder into the joint. Just like that. And we're good to go for the next one, which, before I go any further, actually I'll quickly solder the other half of the escape key in. So, I think I'm going to do... yeah, I'm gonna do these ones next. Yeah, gotta love that. See if I can get that so you can actually see what the hell I'm looking at. You can see, I hope, how that pin's just bent. Nope, that popped. But it is more or less in the right spot, so... ooh. Well, that's annoying. The key had popped out one side because it wasn't in well enough. Oh, wow, that one's really truly well unbent. This one's still not flat in its blasted holes. That's better. This one's still a little off. Better. It's looking good. That's some pretty straight keys. I'm happy with that. Hello, who's IDVSI, huh? Welcome. Okay. Let's do these three here next. doing these in somewhat batch is actually working pretty well. This is probably the most boring part of the stream though. Sorry everyone for how boring this is. I know I can get pre-built keyboards, however they flicker like absolute bloody crazy when you've got photosensitivity. And they don't have as nice key matrix handling as I'm going to be having with this one. That key just came straight out. I designed this from scratch, by the way. Someone had to design the boards that you're suggesting I just used, by the way. Sorry if I seem a little bit defensive on that one, I didn't mean to. Oh, I'm just concentrating and I get, yeah, a little punchy sometimes when I do that. Sorry. Welcome. Hello, brother. Oh, come on, please. Stop being skew whip. You're both very cute, yes. That'll do. Ow. That wasn't because it was hot, I just managed to stab myself with a key on the backside, which is impressive because those are pretty blunt. So, for those who haven't been following this project for very long, or are only just coming here to join in, this is a custom designed RGB keyboard based around Cherry MX keys, but, you know, if I used rear mount sockets, that would work with most keys on the market, which instead of using multiplexing to drive the LEDs, every LED has its own high-speed, high-frequency driver. You can see them right here. So this is a red, green and blue channel driver for a block of LEDs, 24 in total per driver. This means that it's flicker-free. I mean, entirely flicker-free. There is no matrix scanning happening for the LED backlighting, which means if you are photosensitive, you should not have any problems with this keyboard. A lot of the time you see keyboards on camera, and you'll see flicker on like TechTube videos, and that flicker I can actually see, just about, and it causes me really bad headaches. Well, that's a form of photosensitivity, but there are some much worse ones to do with epilepsy, where it's seizure time. Not good. The other thing that this board has is a really nice fast microprocessor here. This is, I don't know who Unicorn Gaming is, but this microprocessor is an Atmel based 80X Mega 256 A3U. It talks USB, it can talk to PS2, and it can talk to all of the SPI that's required to drive these drivers and the key matrix. I've already done this kind of thing before, but not with a keyboard. The previous iteration, if you will, the thing that caused this project to happen is this. This is the center panel from a racing car. This is just a 8-button version, but they can be huge 20-button panels. And on here, those are the same drivers as you see on my keyboard. This is using a PIC microcontroller running at just 4 megahertz. I think it was 4? No, sorry, 20 megahertz. But effective speed is 5 megahertz because it's a PIC, so it's got to divide by 4 on it. And this is able to have a completely remappable button surface. And when I say completely remappable, I mean that every single key can be independently latchable or momentary, and can have its own debounce, its own time to down and time to up, and all of that put together makes for a really excellent experience if you want to turn the debounce and times way down for gaming, but then turn them back up a bit for touch typing, where you want the debounce but you also want the input speed. But also if you've got accessibility problems such as a really bad tremor, you can rack them way up and have like 2 seconds until a key is considered down, to counteract the fact that you might be bouncing on the key really heavily in real life because you can't not, and get a reasonable typing experience. That's the idea. This is also entirely open source hardware and software. I'm not sure what that means. Another of the features of this keyboard and its control surface... Oh yeah, that would be great, wouldn't it? Is that not only is the control surface entirely reprogrammable, you can do so in hardware. So there's an extra key here. This is an extra FN key. And when you press that down and then type other keys on the keyboard, it will start reconfiguration. 9 profiles, so the num keys here are profile keys. So you can physically in hardware store 10 different profiles for the keyboard. And then additionally, the lighting etc. settings can all be customized per profile. So you can have, say, a profile for touch typing as profile 0, a profile for Doom as profile 1, a profile for shoot 'em ups as profile 2, a profile for Minecraft as profile 3, etc. All of which have different configurations of latching, non-latching, latencies, etc. And lighting. God, these keys are really driving me bonkers. They're very springy, now that I've got quite a few in the board. And they don't want to stay in the right orientation. Yeah, that one's now not in the... That's what happened. Sorry, I know you can't see what I'm doing with that, but that needed me to just concentrate on the... Yeah, what I should have done is actually get the metal key plate made, because then I could fit all the keys into the key plate, that'll align them, and then put them in the board. But, you know, hindsight is 20/20. Seeing as these are keys that are designed to go into a key plate. Fun fact. Okay, that's better. One thing that Stream doesn't get across, by the way, is just how quite heavy this board is getting. It's got, as I say, this is a 6-layer PCB, so it was already not a light board when I started. Because there's a lot of inner copper. Oh, come on, stay in the hole. There we go. And that does also mean I've got a lot of weight in this board unpopulated. But now with the keys on, or going on, it's certainly getting heavier. So make this so you can actually see what I'm doing. I'm not very happy with this diode. I've got, I don't know if you can see this on camera, but I've got a very slight bridging happening in there, which was happening before I retouched it. That seems to have blown the bridge clear. That's good. Right. I'll skip the song as soon as I'm not soldering. I need to remember I've got some that I need to remove from the playlist because they've got lyrics in them. Just done that, haven't I? Yeah, and I need to realign that. Excellent. Yeah, I really need to realign that one. Ah. Needs to come towards me. Bottom of this keyboard is certainly getting really, really sharp. That one fell out of the hole. There we go. I'm having to carefully mind as well my dwell times, because these being keys, they don't really like being heated all that much. And that's basically universally true for all keys. They really don't like heat. They're generally made of plastics that don't do well with soldering temperatures. Yeah, thank you. You know how impractical that would be, love? Close. This one's actually still off-centered. Better. Yeah, I'll leave it there, I think. And we'll do these keys here. This is really just... I really hate how these keys were delivered to me. Let's check this other one. Oh, this other one's straight. Pop two in the holes. See if we can do two and keep them more or less straight. Yeah, that was my headphones trying to fall off my head. Wonderful. That's surprising that that's the only one I need to fix of those two. There we go. Yeah, you should definitely sort yourself dinner, love. This is starting to really look like a keyboard, which is awesome. That's a good rabble of extra keys to add on. Ow. They're sharp. Who knew? How to... That'll do, I guess. Huh. That one still needs to be reorientated very slightly. The other one went on fine. Close. Yeah, that's better. Oh, I get to do the last part of wires and do caps lock. Yay! That's how you know it's a real keyboard, right? That's better. Oh, not bad. I've got to reorient that one very slightly, but... This is actually like the perfect music for doing reorientations. Because it makes it seem so much more comedic than it actually is. This was accidental, by the way. This is just in the playlist. I couldn't get that one on straight. Oh well. You know the drill. Sorry for the clattering. That made it worse. Not better. Hey, there we go. Neither of those are on straight. Oop. Close, but not quite. It's one of two. Good enough, I think.
Needs more cowbell.
Please tell me people know what that reference means still. Nearly. That one's not straight. Close enough. That's close. Cool. Let's go through and solder every one of those on fully. Well, actually no, let's finish doing these class 3. Let's get the first of the control keys out of the way. The modifier keys, sorry, I should say. I'll put the extra keys away, because then we'll do some matrix testing next. Because, yeah, I don't want to see me put more keys on. I don't think you want to see me do something a bit different. I would doubt that you want to see more keys being put on right now. Because there's so much space around these, I'm just going to put 3 in, and then I'm going to worry about what's the orientation they're in is in. Is at, rather. Wow, I cannot words here. Ah, those are the alignment posts. They're actually also where the bottom half of the spring system sits and fits. So it's this piece right here, which if you... I'm trying to see if this will show on camera. Kind of. Do you see how it goes darker in colour? Pardon me. Darker in colour as I push the cap down. The very bottom of the plunger actually goes into there. So it's serving 2 purposes. It's served, well, 3 actually. It's serving as a alignment post. It is serving as a spring retention bowl, I guess, and it's also serving as somewhere for the bottom of the plunger to go. Oh, I got most of those actually pretty straight. That's kind of a minor miracle. This one... Once we're going there we go. Ooh, that's probably not very good for the USB port. Whoopsie. That was me dragging the USB port on my desk. seems okay, actually. Okay. Oh, I love this kind of music. It's just so chill and happy. Oh. Is that all the joints that I need to make here? Might be. You're gonna go and sort circuit, love? Good girl. Glad to hear that. So, let's actually see... Okay, let's do two things here. Before I go too much further. Sorry for the camera work there. Not trying to nauseate you all on purpose. So I think test part 1 before I move on is going to be see how the backlighting now looks through the board. That one's still not on straight. Oh well. Then then I'm gonna go and get out my multimeter again, and we're gonna probe some stuff with it powered, but upside down. Ooh. Bang. Sorry. Thanks, dear. Thanks. Ooh, yeah. It's a shame Eston's not in chat, because he'd be oohing right about now, I think. Yeah. Why is that one not backlit anymore? We've had an LED die right here. Huh. Curious. LED 26. Let's go and have a look for LED 26. Yeah, that's definitely 26. Good. Prototype boards for you, though, folks. So it's all channels are dead on that LED. And that's the second pin down on this set of drivers here. Curious. Well, bending it does not help. That isn't making a solder joint come in and out of contact at all. Yeah, I think that might just be that the channel has died on those ones. Same as some of these other ones have had happen. Like, this one over here. Oh, sorry, yes. My bad. So I was pressing down on these drivers and flexing the board a little bit, and no change. Like, not even a flicker from that one. So yeah. Well, let us turn the board over. Ah! My desk is now nicely lit by the board. That's nice. In actual fact, I'm gonna disconnect it again because I better actually clean the board, the flux, before I do the next bit. I'm gonna quickly go and grab some paper towel, so I'll be right back. And back. Make it so you can actually see what I'm about to do. This is going to be really interesting because now I've got sharp things on the board. That are also very, very fluxy because when you're putting this much solder on, my solder produces a lot of flux from the cores. Unlike when you're putting surface mount stuff on. It's great. There's a lot of flux in those joints alone. Wow. Let's put that over there so I don't accidentally thump it off my desk. I better mechanically work some of this stuff off before I hit any more with isopropanol. Oh, that came off as a nice sheet of the stuff. Ah, I missed a joint. I heat my iron back up and we'll fix that in just a second. Those are slithers of metal that I've just removed from the board. That's probably a really interesting song. I'm gonna skip it because of lyrics. I'm getting a distinct Doom vibe from this tune. Yeah, I don't have any acetone. And I'm not sure that the keys are an acetone resistant plastic. This is actually something that isopropanol does really well at. I just don't want to use huge quantities of my stock doing this. So I'm mechanically working off like the worst of it. Because that saves on a lot of solvent. Oh, sorry, that was an awful sound. I mean, actually, heating solvents like that is exactly what's done. What you do is you use a microwave, and you microwave some water in a small thing, and then you take a plastic container with your solvent in, and you plop it in the now hot water for a few minutes, and it heats the solvent up safely. Well, as safely as you can when it is, yes, indeed, a flammable solvent. We'll probably take that. Yeah, acetone polishing is also a thing in 3D printing. So it's far less stupid than you thought it was. Oh yeah, I'm sure. Out of interest, Obliterous, is this a way that you think is a good way to deal with this amount of flux residue with the equipment I have? It seems to work for me, but... It is isopropanol soluble, but there is so much of it, I'm going to blow through a huge chunk of my isopropanol supply if I do just a solvent-based clean. Hence me mechanically cleaning the board a bit first, because it's not adhering well to the solder mask, so allowing me to pop it off quite nicely, as you can see. I'm actually getting whole chunks coming off. Good, good. It also allows me to get rid of all the metal residues that are on the board. Well, yes, there are quite a few pieces of equipment I need. I have actually been talking though with work about potentially getting myself a Patreon account, so in the near future I'm probably going to do the whole becoming a Twitch not a partner, what's the other one? Affiliate. And also getting a Patreon account sorted out so that you can micro donate to me, or you can donate to me monthly for the purpose, the express purpose of upgrading my electronics setup and buying parts and boards for electronics projects you see me doing on stream. Mm-hmm. It's just so much residue. Huh, nice. I'm actually going to need a little bit of solvent on my paper towel to make the residue that I've scraped stick to something. Apparently part of that something was my finger that time. Wonderful. Still, the residue's off now. The only problem with becoming an affiliate, though, is going to be that there will be a 30-second advert pre-roll on all my streams, which I'm not really looking forward to. But if it helps pay, and with the extra features it enables on the channel, yeah, I guess I'm going to become one of those people. And as far as I know, there's nothing you can do about that pre-roll, it's just part of the Twitch platform. I'm sorry for the really bad sounds. This splattered everywhere. That's another piece of metal. What that is, by the way, is that the solder doesn't always cleanly part ways with tip and joint and finish forming into a joint, in which case I'll sometimes get a stringer on the board of solder, which is completely separate from the joint, and which is just floating on the top of the surface of the mask. And it just comes off as a very nice loose piece of metal. But, of course, metal, loose shavings of, in this context, is not a good thing. Because that means potential for shorts. And not the kind you wear. We're close to done with this section at least, so that's nice. So again, this is not the most fun thing to watch, I'm pretty sure. Well, it might be a little satisfying, I guess, because... Get some more isopropanol out. What happens in... Well, first, what is Cura when it's at home? For those uninitiated, like myself. Oh, okay. Yeah. Don't tell me. They went electron. And so it's gone all webby. Am I about on the money? Oh yay. Just what everyone wanted, clearly. Such good usability and such great ability to use it with a screen reader or other accessibility software. Mm-hmm. Fair enough. Oh, yeah, another piece of metal coming off. Wonderful. Is it open source? The reason I'm asking is, it might be possible to fork it and move the improvements onto the old version's UI. Now, if only I didn't have so many projects. And a 3D printer to try it with. I do. Unfortunately, I know QML as well. Like I said, if only I didn't have so many projects. And I had a 3D printer to actually try it with. Fair enough. I need a new piece of paper towel. But at least that is the first pass of cleaning this all done. God, that was a lot of flux. Right, one moment please. One moment please. God, that's actually made my right hand cramp slightly because of how intensive that was. Oh, yeah, that's not good. Good UI is reducing that, not increasing it. Darn it. You know, that's a fair criticism. I think that was one of the things as well that bugged me about Cutter, which is why I went and fixed one of those. There was this problem whereby when you wanted to do custom string stuff in Cutter, which you have to do if you're dealing with anything that is not a C string, you would have to you'd have to right click, navigate down to the right menu entry, click the menu entry, well, open the sub menu, sorry, navigate down to the right sub menu item, and then finally open the dialog to change one number to make the string. Oh, and if you hit enter, it cancels in the dialog, or cancelled because I've fixed it now. And if you wanted to just enter the number, oh no, you've got to click in the right box because it defaults to the cancel button. Yeah, really, the cancel button. Oh yeah, that is a whole thing. So I went and I fixed that because fuck. It is the GUI front end for Redari 2. The reverse engineering tool. It's not bad, but it does need some work. We'll say that much. At least they were very open to UI improvements, so they very gladly took my improvements fairly quickly, actually. So the newest cutter, when it gets released, will not have this problem. So you'll actually be able to open the advanced string dialogues with Shift A when you're on the line that you want to turn into a string, and it will put you in the size box by default, so you can just type a size and hit enter, and that will actually accept the change, not cancel the change. You're welcome. Right, I'll go and put this nastiness in the bin, and then we can get my scope out and we can start probing some things. So one of the first things I'd like to do when we start probing is, don't loot that, is to check the oscillator over here and see what it's not doing and why. So I will go and put this in the bin, wash my hands, and we'll get to it. Should be relatively easy as well to probe because the ground and signal are on this side here, so I should be able to use a spring tip ground and we'll be good. That feels a bit better. Right, let's get my iron out of here for the moment. We don't need to do any reflow for a bit, so... Grab my scope. Now hopefully this is all going to work, because I'm going to try and hook the scope up through Ethernet onto my desktop so that you can see what I'm doing and what it's putting out. We want to keep those handy. There we go. There's the scope plugged into the mains. Let it boot. Hopefully the noise levels stay acceptable. It's got a fan in it, so sorry. I can see how that would be very annoying. So if we use this view, let's see what I can do. I'm gonna need to move you there for a bit. Actually, I can probably look up where this is on my network from in the menus. Okay, that's not so bad. So... the remote I/O is on. This is going to be one of those things where I need to use a viewer on how to do. I don't know what my... Oh, okay, that's because of that. I have utterly forgotten how this works. I don't recall how I do the network viewing thing. And what software I need installed. Oh, what's the name of the thing? Gel something... Gel scope something. Yeah, pulse view is not the tool I'm after in this case. Maybe. Is that in the AUR at all? It is. Operate your iGold oscilloscope from your Linux desktop. Ah, it was Rigel Ultrascope. That's what I used to use, but that was back when I had a Windows machine, and I don't have a Windows machine. I'm just trying to remember what Eston and Co were talking about with regards to waveform viewing remotely. That's really annoying, because there was an OpenGL scope viewer, Scope HAL apps. Let's have a look at what that is. GL Scope client. Let's see whether that's in the AUR. Well, there is that aspect. Oh, that was my neck. Don't mind me. Clicking. Well, I tell you what, we'll give DS Remote a try, because it's in the AUR. I will see if it is happy. It's a QMIC thing, that looks fine. Doing a 16 core build and you're not even noticing. This is great. See if that did the trick. Yeah, because it's a network device, not... That's promising. Hey, you can now see what I see. How about that? I'm gonna actually put like here. so I can... I'm gonna need to move where the camera is. That's fine, I can do that. Not that much lower, honestly. And for what I'm gonna be doing, that's actually perfectly fine anyway. Just moving things around a little tiny bit. There we go. Fair. So, let us set up some probes. I've already calibrated these today, so... Now, love. Right, we'll come back to that second probe in a bit because I don't need it right off the bat, but this one I do need. Good point, Obliterus. Good point. So, let's make it so you can kind of just about see what the hell I'm doing. Oh, really? Yes. That would be great. Also, so expensive to get. It's just, oh. Dear, making me want to cry. I can't afford that kind of scope. Okay, for the kind of signal probing I'm about to do, this giant ground loop is going to be absolutely fine. I've just got to think where I'm going to connect it so that I can probe here nicely. I'm thinking that'll do. Yeah, that feels reasonable. I'm comfortable with that probing setup. So, let's put power on the board. Well, I can see now why that is so very dead. Yeah, that should be the signal pin. Nothing. Not even a hint of life. That, by comparison, that is a nice solid 5 volts. Let's actually make that a little bit easier to see. 1 volt per division. Well, what it could be is I've just simply got the chip on backwards or something stupid. Or it's upside down because the schematic's really hard to understand. That's 3.3 volts, sorry. Could it, like, not show channel 2? There we go. That should be ground. And that is looking very groundy. Oh my! I can see ground noise. That's hilarious. That is also high. Oh, I know why I'm getting that noise. Yeah, because I got a giant ground loop. So... okay. That's pretty much as we expected it to be then, which is good. That's not a bad start. I do now, however, need to get out the iron and... oh, yeah, I could do an SPI line next, sure. I now have to be a little bit careful because if I tap the ground lead on the wrong thing, it will send sparks and possibly even blow my scope probe up. Well, scope up, rather. Oh, that's cool. Single shot that. There's one of the SPI lines. Wrong direction with no, not the position. The position was right. That's what I want. I haven't used my scope in a while, so this is a little... how do I do this again? Oh, that's interesting. You can't see data that's off on the left here. There's actually data here on my scope, which you can't see. Oh. I clicked the wrong position one. I made it unhappy. Interesting. Yeah. Apparently. Oh. Wow, it does not like me using split mode like this. Interesting. I'm gonna turn delayed mode back off. Now it wants to display all the data. There you go, that's what I get to see. Let's actually get a nicer capture though, because this is a little bit nasty. So there's one. There's the red channel. Or, no, that was blue? Anyway, those are 3 different data channels. See if I can... Nice. Just single pulse. Apparently that might be a latch line or something like that. Oh, there's some more data. That actually looks like that's LED drive. No, I recentered the wrong thing again. Let's put that there. Yeah, that's almost certainly no, where's the hold off, there we go. Ooh. And you can't see that because it crashed. Yay! There we go. That's pretty good. So that's an LED output. I'm not going to try and probe anything more right now from one of those chips because, well, they're a royal pain in the arse to do. But yeah, you get the idea. So, I'm going to do a desoldering job on this oscillator, which is going to be so entertaining because of that key. I'm going to probably remove the key as well. So this key's going to come off so I can then get at this oscillator properly. And we're going to pull that off and see what's wrong. So for that, I'm going to need to switch back off of my scope to my soldering iron. Unfortunately, I can either have one or the other, but I can't do both. But I'm willing to bet it's something silly like the chip is just backwards or upside down. Yeah, you should. Please do. Do tell Obliterous. It's not getting hot if you're asking that. Oh, no, what I'm talking about is I think that the footprint itself might... I think the datasheet is so badly written for it that I think I might have the footprint wrong. I think I might not have pin 2 and 3, for example, in the right place on the device. The pin 1 marker, though, for reference, I'll give you the part number in a moment. I need to go and pull that from the schematic, but I don't know if you're going to be able to see this. But I hope you can see there's a little dot right here on the package, so I've got my pin 1 marker on my board here, but also on the package physically there's a white, lighter dot in the corner here. So it it appears, for all intents and purposes, to be on the right way around. So there's no reason it shouldn't have worked. That I can tell. And this is where we get to, as I say, do some parts archaeology. I'm getting you the part number in just a second. I'm having to put my oscilloscope elsewhere so I can get my iron back out. Because whatever we have to do will involve reflow, so... Okay, I've done that, so you won't just get a screen full of ARM again. Let's go with that version of this. There's the... did I get the multi-comp version or did I get the... Oh yeah, they are a total pain in the arse to solder. Glad to hear it. I'm just trying to work out whether it's this one or this one that I actually ordered and used. It's this upper one. There you go, there's the part number, and there's the short link. See, this says pin 1 is indeed in one corner, right where I would expect it to be. Then you've got 2, 3, 4, and 3 is the output. 2 is ground, and 4 is VCC. And now, as far as I can tell, enable control is active high. But if it's active low, I don't have a nice way to be able to make it low without taking the part off, capped on taping over the pad that's the problem, putting the part back on, and then... well, and then... find a grounding point and bodge wire it, I guess, is the finishing part of that. How does this match up to the other one I have in the bill of materials here, the original one? Well, essentially would be yes, because what I'll have done is I'll have isolated the pad that's the potential problem. Yeah. This is the original part. Standby operation, pin 1, ground, signal, and power. And oh, for the love of... Okay, so that would explain then why this one didn't just drop in and replace the first one. How did you figure out how the enable control pin works? Because I'm at the bottom. That is the last part of the status sheet. Well, it says enable control, but it doesn't say active low or active high. Yeah, but, by comparison, the original part I spec'd, you can see here, pad 1, standby operation. Standby operation, logic 1 to enable oscillator output. That's why it's pulled high. That would be that. Here's the Farnell short link. Okay, good to know. In that case, we're taking the thing off just to put Kapton tape under that pin 1, so we can redo pin 1 to be different. They looked pin compatible, to be fair to me, and it is my fault in this case. Cool. That's one key off. Mmm. Well, key's off, so we can now fix this. Ow, that's hot. That's a different finger. I've now just slightly, you can't. If we go back to my schematic real quick, that's a ground. Those are both power. Yeah. I properly dunced this. I'm gonna have to take it off, I'm gonna have to clean the pads completely, and I'm gonna have to Kapton tape pin 1 on the board so that it can't stick onto anything, and then pin 1 gets rewired over the top of the Kapton tape, which I bought Kapton tape so I can do this now. This is cool. We'll probably have to wire pin 1 and 2 to each other over the top of the board with a piece of wire down the side or something like that. Oh, this is going to be interesting. Yes, it will. Pins 2 and 4 are still the right way around. Pin 4 is still power, and pin 2 is still ground. Pin 4, VCC, pin 2 ground, pin 1 ground. It's okay. I kind of got the gist of what you were trying to say, Obliterous, so it really didn't matter too much that you had 2 pins backwards. I understood all the same. I really need to get more solder wick. Oh, hey. Okay. I'm just checking that I didn't fuck this up as I took it off, because it came off quite quickly once it actually came. Looks okay. Oh yeah, so it does. 3-state pin. Wow, they just describe it as the tri-state pin and they don't actually tell you what the bloody hell you're supposed to do with it, even on that datasheet. What the hell, multicomp? Yeah, really. You can see exactly why I thought this was pin compatible though, right? Okay, so what you're saying is just Kapton tape the pad off and just leave it off. That's easy. Well, relatively speaking. I now need to clean the board really good because, that's a bit of a mess. I, however, do need to clean the part up, which is just off of screen at the moment. I already have. That is post-wick. Fair enough. I'm glad that you were reading the datasheets because you've just saved my bacon. So, thank you. And now I have to de-flux everything. I will go and grab myself another piece of paper towel. And I'll also grab the Kapton tape. Funnily enough, multi-comp are the only cheap way to be able to get the damn stuff. Officially. You too. Well, polyamide tape, technically. It's not technically Kapton tape, but it's close enough. There you go. That's what I've got. Looks like it's decent stuff, to be fair. Oh yeah, that's exactly how you want it. Fair enough. Too rich for my blood, for now. Ah, there it is. Like, where's the part gone? Oh no! Oh, it's fine, I've still got it. I just derped for a moment. Fair. Put it in a museum. Keep it somewhere very safe, huh? Because I know that the original NASA stuff is really super rare, so... Ah, nice. That cleaned up quite nicely. I'll give it a look in a moment. SI Labs, yeah. Trying to get SI Lab stuff over here is really hard. And quite expensive. Stop cleaned. Welcome, viable clan member. We have now identified why my oscillator was never working, thanks to some nice datasheet archaeology by Obliterus. We've just taken it off the board and cleaned things, and oh yeah, we've got half the keys on. Along with fixing quite a few of the LEDs from the last time around. Some of them are just dead channeled, so... But, yeah, I have some, fancy new LEDs. Sorry, keys. I'm about to get, Medieval on pin 1's ass right here with some Kapton tape. That's better for me. Okay. So I'm about to use some of this wonderful stuff to make the pin 1 pad float. Tweezers, where did I put that? Oh. Underneath the towel, go me. Wow, this stuff is sticky. Holy! Hmm. There we go. That ain't going anywhere anytime soon, and is definitely never reconnecting with the pin. This is the most elegant bodge I've ever done. I just have to now... mostly flush cut this to the board. There we go. Don't think that's going anywhere. And I think that's never going to break down as far as, you know, insulation of the pad goes. So... this goes back on this way around. Hopefully that is thin and flat enough that this will be fairly easy. I'm going to do this upper pad here, which is my ground, next, as I'll actually solder that, and then we'll start reattaching this beastie and see if it comes up. This almost makes me want to go and get the power supply back out so I can power it up without potentially blowing my desktop up. But we'll see how this goes. Actually, that's really not a bad idea in this case, because this is essentially like I'm doing first light again. Yeah, that's gonna work perfectly, I think. Welcome back. Oh. So, as you can now see, Lethal Bit, there is a little teeny tiny piece of Kapton tape. There we go. Under the pad for pin 1 here, permanently isolating it from the oscillator package. So in theory, that has fixed it. Because Kapton tape is just that awesome. Well, Kapton-like tape, I should really say. Do I have a reader? How do you mean? A reader for what? Oh, I see. Okay, fair enough then. Right, I'm gonna go and put the Kapton away, and I'm gonna get my power supply out, because this feels like it's a very good idea to power this up on the bench supply and do a scope test once we've verified that it comes up without drawing too much current, and see if we've got a clock running. If we do, I'm going to switch to software for a bit. We're at 4 hours and 18 minutes into the stream, and I think we can probably go for another quarter to half an hour on this. I want to go and do that. Oh, interesting. Neat. Right. Power supply, that's right. Getting distracted. Fair. I need to move some things in order to do the next steps. So you need to be way back there, so I can then bend you up and let you see what I'm doing. Just aim to focus right about there. Nice. Now, I have all of the LEDs on this board now. So, who wants to try and figure out with me how much current I need to give this thing? Because my current limit is going to be too low. I can say that blindfolded. Fair enough. I don't think it's going to be under 600 milliamp because 109 LEDs all being driven at up to 4 milliamps. I think it's going to come in on around about an amp. No. Times by 3 because there are 3 channels. $1.3 amps. That's what my calculator says I should aim for. It's all good. I've put a current limit in of 1.35 amps. Wish me luck. Ah, it's running at 2.7. Sorry, not 2.7. 270 milliamps. Oh, right, because... yeah, okay. That's funny. Because this is 50% pulse width modulated, that's all the current it needs. It's not getting hot, so that's a good start. That's the crystal, by the way. I wonder if we can read the frequency from it now. So that's in Hertz mode. I don't know whether it's going to be able to read this or not, because I don't know whether it's going to be too fast. But... hey, what do you know? That's 16 megahertz. Now I want to get the scope probe on it. What I'm actually going to do though is I'm going to put the power supply away and I'm going to put it back on my PC, where we're going to power it up with the programmer on. And we are going to adjust the code that's running on the microprocessor so that it uses the external oscillator that is now up. Removes us from the god-awful internal oscillators that... yeah. We'll see if that improves the way that everything's been behaving, etc, etc, and... That is a really good result, though. I am thrilled with that. So I'll do that BRB thing again. Very power efficient too, at the lower display brightness. I like that. Ah. Doop-a-doop-a-doop. That's not a really good angle, is it? That's probably about as good as you're gonna get. Put the light over the top of it. Oh, the other thing we need to do actually is redress the fact that I haven't yet put the... whoops. I'll be back in a moment. Haven't put the... logic level translator back on after the failed first attempt in the first stream. As amusing as that was. Okay, that's that. Oops, sorry. Thump goes the camera. There we go. Welcome back. We've not put any more keys on, but what we have managed to do is, using a little bit of Kapton-like tape, some phenyl, is it not phenylamine? I'm trying to remember what Kapton's actually made of, what the polymer is, but basically I've put a piece of tape under the pad 1, the pin 1 of the polyamide, thank you. I knew it was nitrogen based, which is why I had a different thing in my head. Which is now permanently insulating pin 1 of the oscillator from its, what was power. And now it's oscillating at 16 megahertz, which is fan-frickin-tastic. So I'm about to crack out the code editors. And we are going to... it's been a while. DMA no, interrupts no. Oh, system, that's why. We want to head into system, and we do want to enable external oscillator, but we don't want the high frequency oscillator at this moment. We then want to re-enable the wait for it to come good, and we then want to set the dividers, external oscillator, and lock. And then set that up. I think that's about right. So, right. Oh, this is going to be entertaining. The last time I upgraded Meson, it broke the build system. So we got to debug that live on stream together. Well, I'm about to fix that. So, what this is that Meson couldn't run some part of the dynamic linker side of things, and rather than saying that, it decided, because they still got to improve the error messages, I mean, give them a break, it is still quite young. It instead says that it was unable to determine the dynamic linker. Go figure. And I don't recall if this log actually says what the hell went wrong. Yeah, the log doesn't actually say what went wrong. What you have to do... yeah, this is a whole thing... Is it private, maybe? No, what I had to do was S-trace Meson last time. Yeah, we need to run a patch onto the Meson people and say, hey, what's up with this? Oh no, it wasn't Meson reconfigure. What? Trying to remember what Ninja reconfigure runs. Scan, build, dist, install, benchmarks. Reconfigure. Wow. What? Oh, it's the regenerate build. There we go. then where's it gone? I have to tell S-Trace to dump the whole of the FD8 read output. Oh right, it's tacky read equals 8. Obviously. Default target, AVR unknown none, invalid BFD target. Huh. Oop. They are, oh, I know what's happened. Bin utils on the host system updated. And now this is trying to pull the wrong bin utils. It was supposed to be R-pathed. If this was properly R-pathed, this wouldn't have happened. This is the whole thing. I'm not saying this is your fault, love, by the way. This is just simply that, This is basically exactly the reason why I build my custom utilities with a R-path in it. Yeah, script's on my system, I'm gonna fix it. I just gotta remember how to. Yeah, so you see here in the dynamic section output, having read that ELF, there is an R path, but it doesn't specify... Oh, sorry, it does specify system paths. That's a problem. I'm not proud that I know how to use S-Trace that well. Trust me, it's not pleasant, so... Where's bin utils? Bin utils, there it is. Let's not do that. Let's just fix the thing. I'm actually also inclined to do the same thing to GDB here. In fact, that actually makes this... Doink. That. And... I think you actually don't need that as a result. That's nice. Because our path implies our path link, so... I think that does the trick. I just have to rerun this script real quick and we'll probably get a working version of those bits out. Just give it a moment. This script, by the way, is thanks to the absolutely amazing and lovable and wonderful Lethal Bit. She is amazing and awesome. You damn well should be. It's great. Oh wow, I've had quite a few people follow me this stream. I have to quickly thank Derek Boom, Grad131, Gentlemen, and Kavok Cavo Cathedral. Okay, I think that's how you pronounce that. Thank you all for following. That was the arm tool chain now fixed up. There we go. Hey, there it goes. Welcome. Ah. Hey, there's my build working. Well, that's interesting. That's, different. Let's not have it keep blinking like that. Why is that happening? We're configuring the external oscillator as having that frequency range, 2 to 16 megahertz, and oh, you can't see this. And so we're configuring it to have 2 to 16 megahertz external oscillator frequency range, and that it's an external clock, so don't try and drive it, it will drive you. Yeah, she's awesome like this. There are a lot of really quite nifty toys on both Bad Arlock Heavy Industries, which is our joint venture, and also our individual GitHub accounts. So it's worth perusing both her and particularly mine. Oh, sorry, mine and particularly her accounts. I'll get those the right way around in a moment. She's actually more awesome than she realizes. It's just trying to convince her of that is tricky. But we're obviously getting out of that loop, because otherwise it wouldn't start blinking like that. And then we do... yeah. We do an IO reg control, enable the oscillator fail in case it does die. We then... do... clock dividers, put it onto the external source, because we know that it's up by this point, and it's nice and cool. And then we disable the internal 2 MHz source, so that instead we'll fail back onto the 32 meg. I'm going to put that into that IRQ and just see if that makes a difference. Oh, won't find a target. No. Nope, that's not really made a difference. Turn that off for right now, so we can actually see what's happening on the board better. Oh. There we go. There's our familiar demo. I tried to do a thing between streams where I'd re-enabled part of the not quite so working logic here, this logic. So it was trying to do wacky crazy things that aren't currently working, hence it worked the way it was working. That looks good. Can we do DMA now? Oh, bright. This doesn't translate well, but that is incredibly bright. Oh, that's better. I'm just puzzled as to why is that broken? What have I done that broke it? But at least we're now clocked off the external oscillator, so that's a nice step forward. So I'm happy that that code's good, as is in the repo. We'll add a to-do. We'll add a to do for the oscillator pin, and we'll fix the one for the 15k ohm resistors. Okay, that hasn't broken anything new, so... But that has just sped everything up a whole pile. Oh, that's interesting. So this half of the board is behaving as I'd expect it to, but this half is doing something a bit weird. If I reset the board, yeah. That's really weird. How can it? And then also, why are these ones brighter? That means that this variable reads out differently on loop-to-loop basis. The brightness of each LED on the blue channel should be proportional to where it is down the matrix. But I don't see a linear fall off in brightness. And it doesn't explain why it's off in these keys here, because they're not at 0 in the matrix, they're somewhere partway down. 0 should be this one, the escape key. Yep. That made it do something even weirder. Wow. What is this doing? Let's just go for a static display again and... Okay, that works. Because red value is currently 1. I took the dependence on I out of the mix. Yeah, that is now completely even. What the... There are 108 LEDs. Sorry, 180 positions of LEDs. I'll get this right someday. Okay, that didn't change anything, but that's weird because I should definitely be changing to make this happen. So whenever this goes overflow, it starts again. Does that fit in there? Oh. Oh wow, 5 hours. I should probably wrap up at this point. Whoa! No, 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 that's not good for anyone. Ow. My eyes. I wonder if, actually, if I reprogram this now with it running slow, we might be able to visually interrogate what's happening. Yeah, sorry about that. This behavior just makes no damn sense. And we can actually see where it's clocking in and out because... oh. So it did. Whoa! Right in time for it to start doing wacky things again. Oh! Right. We can actually see when it's running through the loop because of this LED turning on and off. Yes, that bright flashing is so comfortable to look at. And that's DMA, which is just broken at the moment. Which doesn't make any sense. Yeah, this LED is now the one that's doing the county thingy. What the bejeebers is this code doing? Okay, that doesn't look too insane, except that it's not getting bright enough. Hang on, to nearest chip, 108. No, that's not right. We're going past the end of the boundary of the buffer. Okay. Why is that being allowed? Because there's 2 to 3 expansion between the number of LEDs in the driver chain, even if we're not using them all, versus the number of entries in the buffer. Yeah, so that's red 1. So that bit's right. And we're taking the false branch on ink red, which is right. If we do 0 to 109, but we offset them into the matrix, because this is in reverse, I think. I forget how the matrix works entirely, so this could be partly my derping around with the way that the LEDs drive. And it was red that's out on that one. That's a shame. There are 109 LEDs in use. The matrix through the drivers, though, sorry, not the matrix, the chain length through the drivers is 120 LEDs long, meaning that we are 11 off at this point. Interesting that that swathe there is now not displaying anything. Oh, sorry. Don't worry, you're not the only one getting confused here. Now I've got 2 LEDs out here, well, 1 out, because... No. Yes, 1 out, because that one won't ever be on at the moment. But the red is on that one. Interesting. Oh no, yeah, 2 out. What the... 3 out. Ah, okay. I know what's happened. Oh, this matrix is gonna be the death of us, but oh well. With these drivers, I should have used the high bits, but I've used the low bits, or rather, the low drive lines, where I should have used the high drive lines. Which means that the last, 24 LEDs need to be offset in the chain by 11, because there are 11 channels not used on those driver chips. Yeah. Yeah. I fucked up. Read this as I fucked up. So if we do... not calc, ring. That's what I'm thinking of. It's 24 LEDs per driver, 5 drivers. That's 120. 120 minus 24 is 96, and it's based 0, so it's greater than or equal to 96. Better. Still got one out, which means I got my maths ever so slightly wrong. There we go. Every LED that can light up is now lighting up. For some reason this I to set the blue channel thing isn't working. That's a whole frustration. I'm gonna temporarily take the gamma correction out. Okay. That didn't work as it's supposed to. There should be some LEDs over this end that are off, and they're not off. And also, green is doing that thing again. What does that do? Oh! Oh! That's working better. That is very pretty. Hmm. Now what happens if we put the gamma correction back in? That's... Yeah, okay. So something is wrong in LED color here. Clearly. Why did I make this stud white again? Almost feels like I might have made this broken of my own volition by saying stood white here. Let's see what happens on the red channel, which is the one that should be changing right now. If we make this a UNT8T, Still weirds me out that, like, this one here is writing to its green channel to do this. Actually, that probably suggests I got something wrong with the board for that particular LED. Happens. Or can happen, I should say. Yeah, that one's screen is hooked up wrong, that's why that's not right. That's funny. That's my bad. Yeah, another line for Rev 2, indeed. Wow, that really doesn't like it when I enable gamma correction. Without gamma correction, it's fine, which suggests... Oh... It suggests either we've got an endianness problem. Or what? That's the question. Or what? I guess there's one easy way to know if it's an endian problem. Put all these values in the upper half of the byte. If it's an endian problem, we'll get some funky colors, but they'll stop flashing. I really want to figure this one out. I know that time is ticking. Oh. Good point. I keep forgetting I've got multi-cursor, okay? I'm used to the days when editors didn't do that. There shouldn't be any, that's the thing. Where do we set stud byte up? Stud byte should be an enum class of uint8t underneath the hood, so uint8t and stud byte should be synonymous. Which is actually per the standard, that is how it's supposed to work. What stud byte is though, is it's supposed to be a guaranteed... well, it's supposed to be a guaranteed 8-bit type that represents any valid byte. And it's done as an enum class so that it is type distinct from uint8t, which is strictly speaking an 8-bit number, not a byte. Okay, that hasn't changed anything, but that's... Well, yes, that's probably because I just typed it up from the standard, to be fair. Oh, that pissed a whole lot of things off. Oh. Whoa! Blinky, blinky. Blinky, 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 blinky. That's very not happy again. So it wasn't that. I love Git. That made reverting that table so easy. Oh, I've just worked out why these ones are coming up red like this. These ones are the lowest keys. And then it goes higher. 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 And it's working backwards every time. Ah, jeez. This is gonna make making the key matrix stuff work quite interesting, isn't it? Because we're gonna have to figure out the exact mapping I've gone and built here for keys to LEDs in the driver chain. I went with what was physically simplest rather than what was logically simplest in this instance. I'd have to put the drivers on the wrong side of the board, as it were. Well, yeah, now that we've got that kind of working, we can do that, so that's not so bad. In fact, actually, that's kind of what we've done by putting the red channel, sorry, the blue channel to be the logical index of the LED, which is nice. Pleasing. Let's change the mode in which we're writing the data out, just to see... Yeah, that works the same. That's how you would hope it would be. It's less efficient, I think. Is it? No, it's slightly more efficient, actually. That's why I had the multiple versions. Well, that's very multicolored, but that's wrong. So DMA is still broken, in a fun way. I don't need that cost given what I'm doing there. supposed to get the upper byte of corrected R. Oh, this doesn't help that these are now ints, so I'm trying to debug code that's subtly very different to what I intended it to be. This is really where I wish that we could just attach a debugger, because if I could attach a debugger, I would know what was going wrong. What that requires is I continue slapping at OpenOCD's mug and telling it how stupid it is. Oh, I just noticed that that LED is actually out at the moment. Where was the other thing I had? Oh, it's in here, that's right. That's probably where my maths had gone off by 1. Wow, those are doing some funky things as a result of that change. I've got dancing LEDs on the end here. Amazing. And then they go right if I do that. That's so weird. Oh, that actually suggests that there's a short on this one's blue, perhaps? Well, it looks fine. At least that line can now go. For sure. We know that's working, because obviously it's working. We know that we've got the right code here to write the bytes required. Ah, one thing I can do, actually, that will help us debug this, is if I... don't do that. If I make it so that we OR in the top bits of our... So we shift it up and we also shift it down, so you basically multiply by... is it 010.1 hex I think, is about what we end up doing by doing that. And we'll see if that still works, i.e. does writing something into these low bits matter or not? It shouldn't matter. Yeah, no, it doesn't matter. So that's good. So it's not that it's 16-bit that matters, and it's not where the bits are in those 16 bits that matters. Something is going wrong when we do the gamma lookup. Volatile shouldn't work there, but we'll see if that does. I think that's an error type. What? You're kidding! Oh no, I didn't save, that's why. Passing that as this argument discards qualifiers. Oh. Ah. Okay, that's fair. That's probably because the volatile should actually live on the inside, not the outside. Ah. Line 150 is now bad. 100 and... Well, that error makes no sense. Thanks, compiler. Fine, I'll take the volatile back out because clearly it can't compile with it in there. Well, it's not the const extra. Okay. So, okay, I'll step back and tell you what I'm thinking here and why what I'm doing matters. What I'm determining is if we put static values into the color routine, what the compiler is doing is it is just running the gamma lookup at compile time and putting the right values in and it just works. Great. And that's fine for static things, but it's not fine when we want to do the lookup at runtime. So it's telling me that either my memory map for this thing is wrong in the linker script, or some part of the startup code is wrong and we're putting data in the wrong place, causing the problem again. I'm not sure which of those two it is, considering the fact that the initial value for LED red and ink red are correct, and it's pulsing up and down the way it's supposed to, telling me that those variables are in the right place in memory, in RAM. But it also suggests maybe that the table is in Flash and the compiler is not generating the proper Flash read sequences to actually look up the gamma LUT data from Flash. Which would be hilarious if that is true, By which I mean I want to cry because it's really difficult to get that right, because that means I end up having to generate the assembly for the LPWs, sorry, LPMs, load program memory instructions to actually read out the memory I need. But it would make a whole hell of a lot of sense, I think you can agree, given the behavior we're seeing. Yeah, I'm gonna wrap up at this revelation. Let's see, we did that. No, Alt D. Mark done, there we go. We did not do the key matrix stuff. We did that. We've done that. We've done that. And we've done that. So that's not bad. So we'll quickly write a couple of firmware to-dos. We now know that the we need to investigate the gamma LUT code gen and see if the compiler's outputting LPM sequences like it should, rather than trying to look memory up as if it's mapped, because it's not, because this is a true Harvard architecture chip. So investigate the gamma LPM code gen. I'm happy that we don't need this slower timer anymore, so that can all go back to how it was. That's great. We need to set up the active key configuration data structure in that structure. As a kind of sub item, we need to map out LEDs to physical key locations, because we know that they're wrong. We know that they are effectively backwards and, you know, weird. We on the PCB side of things, LED 24 red versus green is hooked up wrong. I mean, quite clearly. Doop-a-doop. Okie dokie. Thank you for joining, Amy. It's been good to have you along for the ride. I'm just trying to work my way through in my head what else we need to do to make this a happy little board. We can get rid of that because we now know that those two do work identically. DMA is still buggered, but you know. Oh, we need to set up key scanning loop. We need to do. There's one more item I'm trying to think I thought of. Oh yeah, convert the LED data back to UNT8T. I think that'll probably about do it. I'm pretty happy with the progress we've made today. I mean, the board is now, if you will, breathing, literally. And it's very pretty. I am indeed wrapping up. I want to try one last quick thing, because it now should work. And indeed it does. It's now bouncing back and forth between blue and red. I'm maintaining approximately a constant brightness, but of course it's only approximate right now because it's not actually gamma corrected. Oh, sub point to this one. Possibly write a read gamma LUT routine using ASM tricks. I think that'll about do it. So at that point, it has been 5 3/4 hours. We've got a decent amount done. We now have the board running on the proper oscillator. It's nice and stable. We figured out some of the intricacies of why on earth the LEDs were misbehaving, and it's not actually that like the processor was just rebooting or something stupid. It is actually something in the gamma LUT mechanism that we wrote several streams ago. Probably caused by the compiler doing the wrong thing in CodeGen. Let's see, we need to put this key back on. I've still got it out to one side. That's fine. We'll do that in due course. Sure. Will look nice. Yeah, it's been a good stream, I think, overall. Thank you all for joining me, and I will see you next Saturday for... Well, I'm not yet sure whether it'll be more keyboard or more SPI Flash Programmer. I think that really comes on to a community vote that will happen later in the week. But one of those two.